Hello, this is Philip. Today, I will show you how to use Molecular Renderer. Before diving in, let's quickly overview what the program does. It is an all-in-one software suite for modeling nanomachines. It has programmatic structure definition, bond topology generation and repair, cutting-edge quantum chemical methods, molecular and rigid body dynamics, realistic rendering with self-shadowing, and exporting renders for publication. If you want to use Molecular Renderer, you will need macOS or Windows installed on your machine. A lot of people have requested Linux. It's a great operating system, and for most software, it's easy to compile CPU code for Linux. Swift supports Linux and many other languages do as well. The issue comes from GPU code. Advanced hardware features like wave-scoped reductions and hardware matrix multiplication are locked behind vendor-specific APIs. OpenCL does not support wave-scoped reductions, but it's possible to backdoor support, at least on macOS. This is one of the reasons I chose DirectX instead of Vulkan when porting my code to non-Apple platforms. If you have a Linux PC, create a Windows 10 partition on your hard drive. Download the ISO file from the Microsoft website. Walk through the setup process for a fresh Windows installation. The whole process will take you an hour, but it saves me the time of writing another backend. I designed all of my code to run on cheap, entry-level hardware like the Apple M1. Even with 7 GPU cores and 8 gigabytes of memory, you can render atoms at 60 frames per second. If you have a faster display with 120 or 144 frames per second, you will need a better chip. M1 Pro is good enough for these displays. I developed the Windows port on a very old machine with Intel Core i5-4460. It is a quad-core CPU from 11 years ago. Single-threaded performance is one-third of the Apple M1, even though both have the same clock speed. When you make changes to a Swift program, it takes at least 2 seconds to compile and run. This is with the best CPUs and incremental compilation turned on. Older CPUs really show their age when compiling the code from scratch, first time. The M1 Max takes 11 seconds, while the old Windows machine takes 180 seconds. The GPU hardware must be new enough to support wave-scoped reductions. To simplify the code, I also require 32 wide wavefronts. This is why RDNA1 is the oldest supported architecture from AMD. RDNA can compile into both 32 and 64 wide wavefronts. However, even in Wave64 mode, reductions only shuffle data between 32 threads at a time. There is no fundamental reason why the renderer needs 32 wide wavefronts, but the OpenMM backend relies on 32 wide atom blocks for optimizations. Intel Arc GPUs pose a problem because they sometimes use 8 and 16 wide wavefronts. If anyone has an Intel Arc GPU, I can work with you to add support for Intel's flavor of wave-scoped reductions. On macOS, the first prerequisite is to install Xcode. The easiest way is through the Mac App Store. After downloading, open Xcode and follow the setup process. You only need to install the macOS SDK. Next, you'll want to check that the Swift compiler works from the command line. Open Terminal and type the commands that appear on the screen. Make sure the program prints "Hello World" to the console. This is very important. Molecular Renderer is not a typical Swift package. It requires a special combination of compiler flags and environment variables. Do not use the Xcode UI or Swift Run to run the code. Open Terminal and type the commands that appear on the screen. Start by downloading the molecular renderer repository. After entering the package folder, run bash install libraries.sh. Finally, use bash run.sh to compile the code for the first time. In the package folder, double-click package.swift. This should automatically launch Xcode. Navigate to sources/workspace/main.swift. The file should appear as shown on the screen. Next, we will run through all of the tests. The instructions are documented in the repository, and I will not repeat them in this video. Instead, I will play background music and show text on the screen when needed. If you are on Windows, there should be no spaces in your username. This is not recommended in general. For my application, it makes the Swift compiler break down. You can invoke Swift from git bash, but it doesn't work in the VS Code terminal. Early on, I got feedback about the complex setup process. User-friendly CAD programs like FreeCAD will pre-compile all of their C++ code. The dynamic, or scriptable, part relies on a Python interpreter. I have effectively configured a Python interpreter out of the Swift compiler using the flags xswiftc o unchecked. It compiles to native CPU code, and experienced programmers can easily harness multi-core parallelism. This is the hidden cost of combining high performance with flexibility. On macOS, the Xcode setup process does everything for you. It takes care of the SDK, Swift toolchain, and editor functionality. On Windows, the winget package manager streamlines a large portion of this. To start, go into Settings and turn on Developer Mode. It prevents a few errors in VS Code. I have never attempted to run Molecular Renderer with Developer Mode off. Next, open Command Prompt. Check that winget is working and able to report its own version. With a fresh OS installation, I could not use winget out of the box. I'm showing the process I went through to fix it. When I recorded the video, I had to install OBS Studio first. To do this, I repaired Microsoft Edge and updated the Microsoft Store. I guess this also fixed winget. That means most everyday Windows users will not have any issues here. Once winget is working, visit swift.org/install/windows. Copy the first command, which installs Visual Studio. Make sure it says Windows 11 SDK.22000. In the future, this number will change and it will break the instructions in this video. If that happens, revert to this exact SDK version and use the toolchain for Swift 6.2. Go to Control Panel and look for an SDK in the list of installed programs. If it exists and the version is not 22621, delete it. I'll show you what an SDK looks like when I return to Control Panel later. Open Visual Studio Installer. Install the Windows 11 SDK version 10.0.22621.0. Go back to Control Panel and the SDK should be visible. If it does not exist, Swift will fail to build. If it does exist, but the version is wrong, the compiler fails when a library imports the WinSDK module. Go back to the browser window and copy the second command. It will automatically install both Git and Python 3.9. Then it will download the Swift toolchain. Sometimes the console freezes after downloading. During one of my tests, I noticed a 10-minute pause with nothing happening. Apparently, you must click into the terminal window and press Enter. When recording the video, I spammed Enter right away and nothing happened. After about a minute, I pressed Enter again and it immediately finished installing. I don't entirely know what is going on here. Next, check that Swift is working and able to report its own version. You will probably have to close and reopen Command Prompt. Open Git Bash and pin it to the taskbar. Type the commands that appear on the screen. Make sure the program prints Hello World to the console. Next, install Visual Studio Code from the Microsoft Store. Open the application from the Start menu. In the browser, search for the Swift extension for VS Code. Click Install, which brings you to the VS Code application. Now install the extension. For the next part, it is important that you delete the myCLI folder from the previous test. Open git bash and type the commands that appear on the screen. Do not compile and run the code. In the package folder, double-click package.swift. This should automatically launch VS Code. When the application launches, it only shows a single Swift file. You need to navigate to the Open Folder button and open the parent folder. Next, navigate to the Terminal tab in the menu bar. Click New Terminal. From the terminal, compile and run the code. Note that in the future, you will be using run.bat instead of Swift run. Open git bash and type the commands that appear on the screen. Start by downloading the molecular renderer repository. After entering the package folder, run /install libraries.bat. In the package folder, double-click package.swift. This should automatically launch VS Code. Navigate to the parent folder and then the terminal. Enter /run.bat. The code will compile for the first time. Navigate to sources/workspace/main.swift. The file should appear as shown on the screen. By now, the code may have finished compiling. The first time, it sometimes fails due to errors in the package manifest. Just enter /run.bat a second time, and you should have a successful compilation. Finally, ensure autosave is enabled in VS Code. Next, we will run through all of the tests. The instructions are documented in the repository, and I will not repeat them in this video. Instead, I will play background music and show text on the screen when needed.